Question 1. Energy and momentum. An 8.0 gram bullet is suddenly shot into a 4.0 kilogram block. At rest on a frictionless horizontal surface as shown in the figure. This is the figure, so I'm going to draw something real quick. This is the bullet right here. This is 4.0 kilogram. This is the velocity point in here. This is the spring. Goes here. Something like that. Okay. It says the bullet remains lodged in the block. The block then moves against the spring and compresses it by 8.9 centimeters. So it compresses it. The spring consistent of the spring is 1,400 newtons over meters. What is the magnitude of the impulse on the block, including the bullet inside, due to the spring during the entire time inverting during which the block compressed the spring? So we have the spring. So we were given, I equal, when the spring compressed by 8.9 centimeters, we convert that into 0.089 meters. Then the block sets. So once the block stops, the kinetic energy of the block with the blue inside gets changed into elastic potential energy of spring. So you'll have 1/2 V2 equals 1 to kx2, where velocity is the speed of the block before it hits the spring. So we get V equals x. So we have what we were given. So I put given. We know that the bullet is, we'll put that as bullet, block, and the compress of the spring. So spring C, 8.9, spring. So we take that, (0.089 centimeters over 4 plus 0.008, and we get 1.66 meters over seconds. Now we take that, meters equals 4 kg plus 8, g equals 4.008 kg, whereas k equals 1/4, because we know that the force constant, spring constant of the spring is 1,400 newtons over meters. So this is where we get that from. So then, by implying momentum threshold implies change in momentum. So PI minus PF, we know PF equals 0, PI equals MV, which is 4.008 times 1.66 kg meters per second. Whereas we have PI equaling 0 equal 4.008 times 1.66 kilograms meters per second. You will get 6.65 kilograms meters per second, which you can convert into 6.7